Hello students, welcome back to Husky Math. Today we will learn about the chain rule. There will be a function given and inside that function there will be another function. Okay, so let me explain you. It's written if y equals to f of t, that means y is a function of t, but t is equal to g of x, that means t is a function of x. So let me rewrite this. So since y is given as f of t, that means y is a function of t, then we can differentiate this function with respect to t only. So let me write d dt of y both sides. So what I'm doing, I'm just differentiating both sides with respect to t because y was a function of t. So it will be dy over dt equals to d dt of f of t. So let this be equation 1. And as you can see that there t is a function of x. So let me write that also. So here t is a function of x, t equals to gx. So this I can differentiate both sides with respect to x only. Okay, so ddx of t equals to ddx of g of x. So this will implies dt over dx equals to ddx of g of x, and let this be my equation 2. Now here, as you can see in equation 1 we have got dy over dt, and in equation 2 we have got dt over dx. But what if I have to find dy over dx? I will simply multiply equation 1 and equation 2, equation 1 times equation 2. So multiplying equation 1 and 2, you will get like dy by dt times dt over dx. So here, as you can see, this dt and dt will get cancelled and we will remain with dy over dx. Okay, question number 1. Differentiate the following functions with respect to x. So my function is sine 4x. So here we will use the chain rule to differentiate this function. So now let us consider the given function as y. So let y equals to sine of 4x. Here we have to differentiate the given function with respect to x, and since I have written y equals to sine of 4x, so obviously y is a function of x. So we could have done directly here, but since we are studying the chain rule, so we will use the chain rule here. Okay, so now let us consider this 4x as t. So let me consider, put t equals to 4x. T is a function of x. So if I put t equals to 4x, then my this function will be y equals to sine t. Okay, so here, as you can see now, I have two equations, y equals to sine t and t equals to 4x. Now I can say y is a function of t and t is a function of x. Therefore, if I have to differentiate this particular equation or this function, then I have to differentiate both sides with respect to t. So let us differentiate with respect to t both sides. So d dt of y equals to d dt of sine t. So this will implies dy over dt equals to d dt of sine t is cos t. Since ddx of sine of x was cos x, so similarly d dt of sine t is cos t. So let this be equation 1. Now here, as you can see, t is a function of x, so here I will differentiate both sides with respect to x. So here, differentiating both sides with respect to x, then I will get ddx of t equals to ddx of 4x. So this implies dt over dx equals to, now since 4 is constant, so 4 I will write in front, so ddx of x. So this implies dt over dx equals to 4 into 1 because ddx of x is 1. So now let this be my equation 2. Now since we have to find dy over dx, therefore using the chain rule, dy over dx can be written as dy over dt times dt over dx. So from equation 1 and 2, dy over dt is cos of t into dt over dx is 4. So my answer is 4 cos of t. Now we will replace back the value of t. So my t is 4x, so I will write 4 cos 4x. Hence the answer for this question was 4 cos 4x. Next, number 2, my function is tan cube of x. So let us consider the given function as y. So let us consider y equals to tan cube of x. So this actually can be written as tan x whole cube. Okay, so now let me put tan x as t. So put tan x as t. So therefore y can be written as t cube. Since I have written tan x as t, so my y can be written as t cube. Here also I have two equations where it can be seen that y is a function of t and t is a function of x. Now since y is a function of t, so we will differentiate both sides with respect to t. So it will be d dt of y equals to d dt of t cube, and this implies dy over dt equals to 3t square. And here, since t is a function of x, so we will differentiate both sides with respect to x. So it will be ddx of t equals to ddx of tan x. This implies dt over dx equals to ddx of tan x is sec square x. Now we have both the values of dy over dt and dt over dx. Now we will multiply these two equations to get the value of dy over dx. Therefore, dy according to chain rule, dy over dx equals to dy over dt times dt over dx. So it will be equals to 3t square sec square x. Now let us replace the value of t. T over t means tan x, so it is tan x whole square sec square x. So you can write 3 tan square x sec square x as your answer. So number 3, my function is e to the power x to the power 4. So we have to use the chain rule whenever there is a function of a function. Now since here there is exponential function, and on the exponential function we have algebraic function also. Okay, so here it will be easier if we use the chain rule. So let my function be y. Let y equals to e to the power x to the power 4. So let us put t as x to the power 4. Then my y will be e to the power t. So my equation is y is a function of t and t is a function of x. So here differentiating both sides with respect to t, because y is a function of t, so it will be ddt of e to the power t. This implies dy over dt equals to e to the power t. And here also let us differentiate both sides with respect to x, as t is a function of x here. So it is ddx of x to the power 4. So this implies dt over dx equals to 4x cube. Therefore, dy over dx can be written as dy over dt times dt over dx, and that will be equal to e to the power t times 4x cube. Let us replace the value of t. So it is e to the power x to the power 4. So this is your answer for this question. Next, question number 4. My function is cos, and inside cos there is x cube e to the power x. So let y equals to cos of x cube e to the power x. So let us put t equals to x cube e to the power x. Therefore, my y can be simply written as y equals to cos t. So y is a function of t and t is a function of x. So differentiating both sides with respect to t, we have ddt of cos t. So this implies dy over dt equals to minus sine t. Now here you can see that t is a function of x, but did you notice that there are two functions getting multiplied, that is algebraic function and exponential function. So whenever there are two functions getting multiplied like this, we have to use the product rule. So my product rule, let me write for you once. So it is ddx of u times v equals to u dv over dx plus v du over dx. So here my u can be considered as x cube and v can be considered as e to the power x. So using this product rule, so differentiating both sides with respect to x, then it will be ddx of t equals to ddx of x cube e to the power x. So using that product rule, let me write x cube first, differentiate the second, that is ddx of e to the power x, plus write the second function, differentiate the first. Okay, so now it will be equals to x cube ddx of e to the power x is e to the power x plus e to the power x into ddx of x cube is 3x square. So here it will be, I can see that x square and e to the power x are common. So here inside it will remain with x plus 3 only. Therefore, dy over dx can be written as dy over dt times dt over dx. So it will be equals to minus sine t into x squared e to the power x plus 3. So let me put back the value of t, then it is minus sine x cube e to the power x times x squared e to the power x plus 3. It would be better if I write in this way, minus x squared e to the power x plus 3 times sine x cube e to the power x. So this is your answer for this question. So this is how we do the chain rule.